So for today, we're going to have another discussion. But before that, let's have this reflection. Let's reflect on this. So if you were to compare your relationship with your best friend, into what object will you compare it and why? So I want you to think, okay, of an object that will represent your relationship with your best friend. Then you are going to think of the reason why. Okay, so I'm not going to ask you one by one, so you know already what object is that and what is the reason why you are choosing that object. So for today, we are going to deal with relationships among lines. So these are the tasks. First, we are going to identify the different kinds of line and the subsets of a line. We're going to illustrate each kind and subset of a line. And we're going to determine the measurement of a line segment. So let's get started. First, again, I'm going to ask you this question. So how important is the understanding of relationships among lines in one's life? So I hope at the end of our discussion, you are going to understand the importance of lines. So kinds of lines. So first, we're going to deal with the following. So we have parallel, we have perpendicular, intersecting, concurrent, and skew lines. So let us discover the differences and the similarities of these lines. Let's have the first one. So parallel lines. So lines that are coplanar and do not intersect. So this one, if we have this line AB, so that is parallel to line MN. So in symbol, we have the two vertical lines in between line AB and line MN, meaning that that is parallel. Okay? Okay, next. So how about this? So coplanar, meaning that is on the same plane. So we have, if we're going to name the two lines, we have line MY and line BE. So that is parallel, and line MY is parallel to line BE. So how about the perpendicular lines? So these are lines that intersect and form right angles. So again, perpendicular lines are lines that intersect and form right angles. So if we have right angles here, so the measure of the angles are 90 degrees. So line AB is perpendicular to line CD. So this is the symbol. One vertical line and the other one is the horizontal line. So that's inverted T. Okay, so that is for perpendicular. So how about this one? So if we're going to name the two lines, we have a line WX is perpendicular to line WZ. So in symbol, so that is the symbol for perpendicular lines. Questions? Okay, none. So how about this one? Intersecting lines. So what's the difference between the perpendicular line and the intersecting line? So intersecting lines are lines or coplanar lines that intersect. So we have here coplanar lines so that intersect, meaning there is a point of intersection between the two lines, and that is point A. So A is the point of intersection of the two lines. So the two lines are line RS and line MN. So in that case, we have, if this one, so point S is the point of intersection of the two lines. So meaning line TH, okay, and intersect with line MA at point S. Next, how about the concurrent lines? So concurrent lines are three or more lines that intersect with a point. So these are intersecting lines, but three or more lines. So we have first one, second one, third, and fourth lines. And those lines intersect at one point, and that is point A. Therefore, A is the point of concurrency of the lines. So if there is a point of intersection for intersecting lines, so for concurrent lines, there is a point of concurrency. How about this one? So we have 5 lines that intersect at R. So this point R, or R, is the point of concurrency of the lines. Okay, so how about this skew lines? So skew lines, non-coplanar lines that do not intersect. So non-coplanar meaning that is not on the same plane. So if this is the case, okay, so the other one is on the other plane. So this is non-coplanar and they do not intersect. So line AB and line XY do not intersect. Next, this one and the other one. So line AC and line LO do not intersect. So these are skew lines. So let's deal with subsets of a line. Okay, so we have segment. So if we look for the subsets of a line, so we have segment and array. So what is the difference between the segment and array? If you're going to look at the illustration. So remember that a line segment, a measurable part of a line that consists of two endpoints and all the points between them. So there are already endpoints. So there is no arrow to the left and to the right if we are dealing with segment. So this is an illustration of line segment. So that's line segment AB. So if you're going to compare the symbol for line segment and a line, so in a line we have two arrowheads, opposite arrowheads, but here we do not have any more arrowheads, meaning there is already an end that is only for A and B. Okay, for C and D, so it is read as segment CD or segment DC, or in symbol we have segment CD or segment DC. So for the next one, we have also the ray. So ray, it is a subset of a line that has one endpoint and one arrowhead that goes in one direction. So this is an example of a ray. Okay, so there is a one endpoint, point A, and another one, okay, arrowhead that goes in one direction or to the right. So that's B. So ray AB. So if we have a symbol for line, two arrowheads here, for the ray we only have one arrowhead. Okay? So not BA. So we cannot interchange the name for array because of the arrowhead represented by letter or point B. Okay? So not BA. So for this CD, we have ray CD or ray CD not DC. Okay, so kung nasaan po yung arrowhead, yun yung last letter that we are going to use. Alright. So opposite rays. So two rays are opposite rays if and only if they are subsets of the same line and have a common endpoint. So here we have opposite rays. So they have the same endpoint and that is point A, right? So we have also here not opposite rays. Why? Okay, though they have the same endpoint, point A, so that is not a line. Okay, so a line as ray DE and ray ED are not opposite rays. Ray DE and ray ED are not opposite rays. Okay, because they do not have the same endpoints. Okay? Okay. So next, how about this? So ray MA and ray ATH are opposite rays because they have the same endpoint, the point A. So ray MAT and ray TH, so opposite rays. So ray MA and ray TH are not opposite rays. They do not have common endpoint. Okay? Okay, clear? Yes, miss. Let's proceed. So how is a line segment differ with a line and array? So if you're going to look at the illustration, so for the line segment, we have two endpoints. For the line, we have two arrowheads, meaning it will go continuously. But for the array, we have one endpoint and one arrowhead. So line segment is measurable. So there's definite length for our line segment. Okay? Okay, so let's proceed to the distance postulate. So the distance postulate, to every pair of distinct points, there corresponds only one positive number called the distance. So we are going to get the distance from point A to point B or so on and so forth. So in this case, we only have the distance of 2 points, and that will be for the distance postulate. So properties of distance between 2 points. So the distance between two distinct points is positive. The next one, the distance between any point and itself is equal to 0. So obvious. And the third one is the distance between 2 points does not depend on the order on which the points are mentioned. Thus, it is always true that AB is equal to BA. It can be interchanged. Okay, so let's use the ruler postulate. So the points on the line can be placed in a one-to-one correspondence with real numbers so that to every point on the line, there is exactly one real number. To every real number, there is exactly one point on the line. And for number 3, the distance between any 2 points is the absolute value of the difference of their coordinates. So let's see. Number line. So the number line can be viewed as an infinite ruler that is used to measure the distance between any 2 points. So we have also the coordinate system, so the correspondence between the set of real numbers and the points on a given line. So the number corresponding to a given point is called its coordinate. So the coordinate is -5, 0, 4, or 3.5, 7, and so on and so forth. So the capital letters are the names of the points. So LOV. So finding the distance. So how are we going to find the distance from LO, from OV and VE? So let's see. XY is equal to the absolute value of the first coordinate minus the second coordinate. So example, distance between L and V. So the coordinate of L is -5 minus the coordinate of V, which is 2. So getting the absolute value, we have 7. Right? So 7 is the distance from L to V. How about OE? So if that is OE, we have the coordinate which is -1 and 5. So that's -1 minus 5. The answer is -6. Absolute value of -6 is 6. Okay? Find OV, VE, LE, LO, and EL. So I think you can proceed, or you can answer the following distance, right? Because we're just going to get the coordinates of the 2 points, and after that we're going to subtract. After subtracting, we are just getting the absolute value. Always remember, we are getting the absolute value because the distance is always positive. Okay? Okay, next. So let's have this activity. So I will give you time to do this activity. Okay? So if you're done with this activity, so you may answer this question now. What have you learned for today? So similar to the questions before, how importance, or what is the importance of knowing the relationships of lines, okay, in our lives. So I hope that you are getting into that question and reflecting into that particular question that will lead you to the appreciation of these concepts. Okay, so if you do not have any questions, I think that's all for today. Thank you.